drawn at one end of the lattice rectum of the ellipse with the eccentricity A, if it passes through one end of the minor axis, right? Okay, let us see. I have drawn a normal at one end of the lattice rectum. When it passes through one end of the minor axis is the first question. Let us see. What's the equation? I go to this one is, the solution of this one is. So, equation of normal at L of AE comma B square by A can be taken as x1, y1, right? Is given by a square x by x1 minus b square y by y1 is equal to a square minus b square. Yes, this is the equation of normal to what? To the ellipse x square by a square plus y square by b square is equal to 1. Right? Now I will write this one as a square x by x1. You take this as a minus b square y by b square by a is equal to a square e square. Right? Now, if you want, you can cancel out. 1a get cancels. We left with x by a minus that is ay is equal to a square e square. Now, a square minus b square is given to be a square e square. According to the eccentricity formula, b square is equal to a square into 1 minus e square, right? So therefore, I got it. You make this as a 1. Right. Now coming to this one is case 1. What's the case 1? First question. First question is, when the normal drawn at one end of the lattice rectum passes through the one end of the minor axis, when one passes through, yes, b dash of 0 comma minus b, right? So here it cannot pass through this, right? Okay, the normal cannot be a parallel to the tangent at L. So therefore, when the normal drawn at this point passes through B, when the normal drawn at L passes through other end of the minor axis, okay? So therefore, passes through 0 comma minus B, then 1 implies, right, 0 plus AB is equal to A square E square. 1 a goes. Now squaring on both sides, b square is equal to a square into e power 4. This is given to be a square into, that is a square into 1 minus e square is equal to a square into e power 4. This sign just get cancels. Therefore, we obtained e power 4 plus e square is equal to 1 is the one simple condition. Later, if I go to this one is case 2, this is one of the important question. From this you can expect after arguing like this. Yes, if e power 4 plus e square minus 1 is equal to 0 is the condition for the normal drawn at one end of the lattice rectum to pass through the what? One end of the minor axis. Then if this is the condition, what is e square? I can write which is a quadratic in e square, therefore minus b, yes, plus or minus square root of b square minus 4ac upon 2a, right? So therefore a is equal to 1 into 1. Now e square cannot be negative, so therefore 5 square minus 1 by 2. You can also write in terms of as a sine function or cos function, depends upon this. So therefore, e square is equal to root 5 minus 1. Coming to case 3. Case 3 means it's another question. So what's the question? If the normal drawn at one end of the lattice rectum of the ellipse, so meets the major axis at G, then what's the condition? CZ. Yes, now I will write when one meets the major axis major axis at G, right? Then the question is CG is equal to dash, right? We have to find out. Okay, when the normal drawn at L, if it meets the major axis at G, okay, at G, right, at G, y is at G, I can write y is equal to 0, right? When y is equal to 0, so therefore 1 implies, right, 1 you take, that is ax by a minus ay is equal to this. This becomes ax by a minus 0 is equal to, I can write a square e square, right? 1a goes with this one. X is equal to what? ae cube. Therefore, g is equal to ae cube comma 0. Center is, what is C? The center of an ellipse, right? The center of an ellipse, that is 0 comma 0. So therefore, CG is equal to, apply the distance formula, that gives CG is equal to ae cube. Yes, these are the discussions, argument on one problem, right? It can be taken as one of the simplest passages, right, for the advance and all. So whenever the normal drawn at one end of the lattice rectum, right, if it passes through one end of the minor axis, this is the condition, e power 4 plus e square is equal to 1. The second question is, if the normal drawn at one end of the lattice rectum passes through one end of the minor axis, then e power 4 plus e square is equal to 1. Then what's a e square? This is root 5 minus 1 by 2. Meanwhile, so when the normal drawn at one end of the lattice rectum meets the major axis at G, then CG is equal to dash, means it's a ae cube. In this question, if the tangent drawn at a point t square comma 2t on the parabola y square is equal to 4x is same as normal at root 5 cos alpha comma 2 sin alpha on the ellipse x square by 5 plus y square by 4 is equal to 1, then which of the following is not true? This is one of the important multi-layer questions for advance, right? So therefore, that is tan alpha is equal to plus or minus 1 by root 5. Alpha is equal to minus tan inverse of 2. Alpha is equal to tan inverse of 2. Alpha is equal to tan inverse of 4, right? Okay. Now, first we find out the equation of tangent at this point. Equation of, right, tangent at p of x1 y1 is equal to t square comma 2t, right? 2, yes, is equal to y square minus 4x is equal to 0. Is s1 is equal to 0, or else directly you can write a parametric equation of a tangent to the parabola is y1, right? y1, what is your y1? 2t, right? Minus s2 into x plus t square is equal to 0, right? Now this becomes yt minus x minus t square is equal to 0, right? If you want, you can write x minus yt plus t square is equal to 0. You call it as 1. Similarly, equation of normal, okay, at, that is a q of, right, I can write this one as q of root 5 cos alpha comma 2 sin alpha. If you want, you can type this as x1 comma y1 is given by a square x by x1 minus b square y by y1 is equal to a square minus b square, right? So therefore, I can write this one as, now a square is 5x upon x1. What is your x1? Root 5 cos alpha, right? Now minus b square 4 into y upon, this is a y1 2 sin alpha, right? 2 sin alpha, a square minus b square is equal to 1. This becomes root 5 into secant alpha into x, right? Next, minus 2, that is 2 into cosecant alpha into y is equal to 1. You call it as 2. Now, since 1 and 2 represent same, now you compare the coefficients. I got it since 1 and 2. Yes, 1 and 2 represents 1 and 2 represents same. Okay, same, right? Now compare the coefficients of like terms. I got it sin alpha is equal to minus 2t. Then you compare this one is I'll get this cos alpha is equal to, that is minus root 5 into t square, right? Minus root 5 into t square. So we got it, sin alpha is equal to minus 2t, cos alpha is equal to minus root 5 into t square. We know that since sin square alpha plus cos square alpha is equal to 1, so therefore I can write substitute. This becomes 4t square as 5 into t power 4 is equal to 1, which is a quadratic in this. So therefore t square is equal to minus 4 plus or minus square root of 16 plus 20 upon 2a, it's about a 10. So therefore I got it, that is a t square is equal to minus 4 plus or minus 6 by 10. Therefore t square is equal to, yes, 2 by 10 is equal to what? 1 by 5. T square cannot be negative. What is t square? If you want, you can take, yes, t is equal to plus or minus 1 by root 5. Take these values and substitute here. Where is that? Sin alpha is equal to minus 2t, cos alpha is equal to minus root 5 by t square, by using plus value as well as minus value with respect to the different values of t. Yes, you can verify the what options. That's it. In this question, if a tangent of slope 2 is a normal to this circle, x square plus y square plus 4x plus 1 is equal to 0, then the minimum value of AB. Now I will write the equation of tangents to ellipse, right? To ellipse is y is equal to mx plus or minus square root of a square m square plus b square, given m is equal to 2. Therefore it becomes y is equal to 2x plus or minus square root of 4a square plus b square, right? You call this as a 1. Now 1 is a normal, right? Always normal to the circle, normal to a circle. What's a circle? X square plus y square plus 4x plus 1 is equal to 0. Its center is given by minus 2 comma 0. So the tangent to the ellipse is a normal to the what? Circle. Certainly normal always passes through its center. Take x is equal to minus 2, y is equal to 0, then 1 implies, right? Yes, 0 is equal to minus 4, right? Plus or minus square root of 4a square plus b square. So which implies 4a square plus b square is equal to 16. Taking, that is 2a and b as a positive quantities, I can apply am is greater than or equal to gm. Right, 4a square plus b square upon 2 positive quantities. This is nothing but, yes, 2 into 4 into ab whole square. So therefore 4a square plus b square is equal to 16. 16 upon 2. This 4 will come outside with the 2, and also ab it is this and that cancels, which implies ab is less than or equal to 4. That's it. Given if the ellipse meets this ellipse in 4 distinct points, okay, and a is given by b square minus 10b plus 25, then b does not belong to dash. Whenever two ellipses intersect each other, certainly one ellipse must be a horizontal, other must be a vertical for this major axis, x-axis. for this major axis, y-axis. Certainly, when you take here, a must be greater than 1. So therefore, you are given with b square minus 10b plus 25 greater than 1. Factorize minus 10b plus 24 greater than 0. If I factorize b minus 4 into b minus 6 is greater than 0, I can write this one as b belongs to minus infinity 4 union 6 to infinity, or in other way I can write b belongs to r minus closed interval 4 6. Now check the options that gives the required answer. So here the points of intersection of two ellipses represented by S1 and S2 is a circle of radius and center dash. Okay, now we are given with two secondary curves. Whenever we are given with the secondary curves, with that we have to find out a circle passing through the points of intersection of those two. Required circle is given to be S2 plus lambda S1 is equal to 0. Yes, substitute. It becomes 4x squared plus 2y squared minus 20x minus 12y plus 35 plus it is a lambda into, right? Lambda into x squared plus 2y squared minus 6x minus 12y plus 23 is equal to 0. Yes, simplify. This becomes 4 plus lambda into x squared plus 2 lambda into y squared, right? Okay, minus 20 plus 6 lambda into what? X minus 12, okay, 12 plus 12 lambda into y plus 35 plus 23 lambda is equal to 0. This is the equation of circle when one represents a circle, right? Circle, which implies coefficient of x square is equal to quotient of y square. So therefore 4 plus lambda is equal to 2 plus 2 lambda. So therefore I can write lambda is equal to what? 2. Yes, take this lambda is equal to 2. Substitute, you are going to get the center as 8 by 3 comma 3 and a radius is 1 upon 3 into square root of 47 by 2. In this question, let S of 3 comma 4, S dash of 9 comma 12 are the foci of an ellipse, and the foot of the perpendicular from S to a tangent is P of 1 comma minus 4. Then E is dash eccentricity of an ellipse. According to this, for this ellipse, I have drawn a tangent. For this tangent, P be a foot of the perpendicular from foci, that is S or S dash, right? Okay, now if I take P, if I take this as a Q, as you please, foot of the perpendicular means here the secrecy of the point P is the position. Where does it lies? We have to locate. According to the definition of auxiliary circle, the locus of feet of perpendicular from a foci to the tangent is known as a what? Auxiliary circle. But in ordinary way, we speak the definition of auxiliary circle is the circle with the major axis as a diameter is a what? Auxiliary circle. That is mere waste. But this locus concept is most important. The locus of feet of the perpendicular from the foci to the tangent is nothing but an auxiliary circle. By knowing this, now P location, we came to know that where does it lies? It lies on auxiliary circle. Let us find out the center. This is nothing but s plus s dash by 2. This is 9 plus 3, 12. It's a 6. 8 plus 4, 16. It's a 8. Okay. P is given to be s1 comma minus 4. Now I want to find out the radius of auxiliary circle is nothing but length of semi-minor axis, major axis. A is equal to, apply the distance formula. This becomes 6 minus 1, 5, 5 whole square, 25. 8 plus 4, it's a 12. It's a 144. It's nothing but 30. Meanwhile, we know that SS dash is equal to 2AE. SS dash is equal to 2AE. Means the distance between S and S dash. Apply this 9 minus 3, it's a 6, 36 plus 64. How come? 12 minus 4, 8 whole square, 64 is equal to 2 into 13 into E, which implies E is equal to 5 by 13 is the required answer. And this problem is important for any type of exams.